Our first presenter today is Emre Cinar from Nokia. Emre is a junior automation sales engineer for IP networks at Nokia, supporting network automation sales activities across the European market. Please join me in welcoming Emre to the stage and enjoy the talk.
Thank you guys, happy to be here. So welcome to my presentation, Making Network Automation Consumable, a junior engineer's perspective. So first of all, who am I? That's the question everybody always asks. So I'm Emre Cinar. I'm a junior automation sales engineer at Nokia Germany. I'm specifically part of the NSP automation team. NSP stands for Network Services Platform, which is our IP1 controller. And yeah, normally at this point, people start to talk about how long they've been in the industry and how much experience they have. I'm sorry, but I will need to skip that part. I've just finished my bachelor's degree last year, and I've been working for a year now, so there's not a lot to tell about that, unfortunately, yeah. But yeah, the past year I've been just trying to navigate the space of network automation somehow, and the more I got into it, the more I was like, okay, there's a lot to cover. There's really a lot to cover as a junior engineer, and I thought I want to make this aware to senior engineers so that they can support their junior engineers better. So a couple months ago, my boss came up to me and was like, Emre, please prepare a service provisioning use case for a customer of ours with his tools. And I was like, okay, what do I need to do for that? What do I need to know for that? And I started talking to a few senior colleagues, and the more I talked to them, the same question kind of appeared throughout all the people I've talked to, which was, if you could start over, what would be the first thing you'd learn? Or if you could talk to your younger self, what would you tell them? I know this kind of question usually leads into telling their younger self into buying Bitcoin right away, but let's focus on network automation here now. So the more I talked to people about this, the more I was able to kind of pinpoint three different, I call them pillars, three different elements. So, which are, I call them network infrastructure knowledge, cloud native technology, as well as software engineering. So first of all, we have network infrastructure knowledge, which is straightforward. If you want to automate something, you should know how it works, right? You want to know what you automate. So this includes everything around hardware fundamentals. So you want to know what is an SFP, what kind of CPM cards do I have in a router, and so on. As well as on top, we have the different operation systems across maybe multiple vendors, across one vendor, and the separate CLIs as well. And last but not least, the network architecture and protocols that you need to know. You need to start somewhere, right? You need to know what IGP is, you need to know what MPLS is. And yeah, I remember I was in a discussion with a couple of friends and I just finished learning about IGP and they were talking about LSPs. And I was like, I finally know what you guys are talking about. Link state PDU. And they were like, yeah, I'll give you a couple months more. You're not there. You're getting there, but you're not there yet. So that's the first one. The second one is cloud native technology, which is all about containerization. How do I put my application into a container? How do I scale it afterwards using Kubernetes? And how do I do that in a methodology that helps me improve it continuously over time? So CI/CD, continuous integration, continuous development methodology. So this kind of is appearing everywhere for me as well when it comes to automation, because you don't want to test on hardware anymore. You want to have some virtualized way to test your routers or automation as well. So this becomes even more important because of that. So this is another complete pillar that you need to focus on when working in automation. And last but not least, we have software engineering. This is probably the one I'm most familiar with just out of university, because you do basic software engineering university as well, but this still covers some complexity, as in I saw Python and Go were like the most popular as far as I've seen in the network automation space, as well as all the packages and all the ecosystem on top that you need to cover for this, like NetMiko, PyTest, and so on. And last but not least, we have the data formatting, which for me is basically how do I convert everything that I'm getting into JSON. So we have the 3 pillars. There's quite a lot of ground to cover. Technically, there's a new player as well. I'm just not going to cover that out of simplicity. Like, we've been hearing about AI everywhere. How do I use AI agents for this? How do I use MCP to connect to a network controller and so on? But as a junior, usually you first need to know what you're doing before you get to that level of automation. So out of simplicity of all this talk, I'm just going to skip it for now. But the focus, what I'm trying to underline, is that the network automation field is just vast. There is a lot to cover. There's a lot of ground to cover here. And there's a lot of topics that you need to kind of have an idea on to be able to pull off automation. And to get to my point of this presentation as well, imagine on top of these 3 pillars, we still have loads of tooling that is supposed to help us on our journey towards automation. And imagine if that tooling is so complex, it turns into a bottleneck to actually pull off the automation in the first place. Let me give you an example. Imagine you would like to learn about an IGP protocol, SPF, ISS, whatever, and you want to configure it on a router. But just setting up that network takes you multiple hours or multiple days, depending on if you need to get hardware as well. Then that tooling or that step turns into your bottleneck for actually trying to learn IGP in the first place. That's why I'm getting to my conclusion here, which is consumable tooling is crucial for juniors. So what do I say, or what do I mean when I say consumable tooling here? What are consumable tools? I kind of summarize that for myself with 4 attributes. The first one is minimal dependencies. It seems quite straightforward. I had a situation where I was trying to install a monitoring solution in a security environment, so no access to the internet. And at that time, I tried to download all the RPM packages I needed for that manually, put them on a separate server, and rewrite the YAM repo. Let's just say that it took me 1.5 weeks to install that one software because I just had dependency issues. And nowadays, I know I can pull it off easier with Docker, but at that time, I didn't know that. I had to do it myself somehow. And yeah, I spent 2 weeks on that, but the only thing I actually wanted to do was learn how to do proper monitoring of my infrastructure. But I wasn't able to get to that until 2 weeks later. So documentation, this is quite straightforward. Nobody likes to reverse engineer how a tool works. I think we've all done it at some point. But yeah, I think that's why documentation is quite straightforward. Real world examples. I like to compare this to school, actually. For example, physics felt more meaningful to me than maths because I was actually I actually knew what I was using these equations for in the field. And the same applies to tooling. If you teach a junior on how to, or if you teach him about a new tool, and if you tell him how to use that tool in the field as well, he's much more likely to be able to use that tool in the field as well because he has an idea and a vague idea on how to use it later on as well. and supportive community. I think this one is technically not a direct part of the tool, but is something that the creator or the publisher of the tool can foster and enforce, so that you have a way to ask questions. Because let's be honest, you could be junior or expert, you will always have some questions, and that's what these communities are for. So, I talked about consumable tools. What are tools to help me in the beginning, especially? So the first one is Container Lab. I hope you joined our workshop on Sunday by Gordon over there. It was a really good workshop. If you didn't have access to it yet, let me know. I'll share you the GitHub repo. But basically, Container Lab is a tool to deploy virtualized networking topologies and networking operation systems. It helped me a lot in the beginning. Just to be able to say, hey, I want to learn this, I can deploy it right away and just test whatever I need to test. And it actually fulfills the attributes I was talking to beforehand. So we have a quick start guide, so it's no dependencies, because I can just deploy it right off the box. I have real-world examples of how to use Container Lab through pre-prepared labs. I have an active Discord server for community help. So all these factors make it really easy to use Container Lab for me. And the second one for me is Netbox. Let's be brutally honest here at first. I know inventory management can be quite miscellaneous at times, but especially as a junior at first, when you start recording serial numbers and do that for a while, you know, I want to automate this. I don't want to do this anymore. And that's where Netbox comes into place. And it's a great tool to do that. And the same principles apply to Netbox as well. So we have a quick start guide for exploration. We have great documentation. Where I was working a lot with the Swagger UI, love that. And an active Slack group for community help. So we have these two tools. You might have noticed these are open source tools. So on top of that, obviously, we also have the commercial tools, which add another layer of complexity to all of this. I just want to spend 2 minutes on this real quick, because I've been talking about the service provisioning use case beforehand, and it's a mixture of both. And what I want to underline here is that open source is powerful because it fosters innovation and collaboration, but obviously it requires effort for your specific use case. Commercial tools are efficient, but they come at a price. I don't want to make I don't want to have a discussion here between the two of them. I would say for most of them, it's less about choosing sides. It's more about choosing works. Choosing what works, because in the end, reality demands it, and that's where the balance lives for all of us. So, I was talking about the service provisioning use case in the beginning. So, what was that about? What did I need to do over there? And I would just want to do like a quick run through of how the tools I've been talking about beforehand made it easier to pull this off in the first place, and use it as an example to underline that. So the use case was basically about a layer 3 VPN service that you can see over there. And we have multiple provider edges, or PEs, connected to separate customer edges, CEs. And the idea was that the customer previously was recording the connection between the PE and the CE manually in an Excel file. And that can be quite tiresome over time, right? Nobody wants to sit there and say, hey, there's a new link. I will need to connect it in an Excel file. And over time, it just gets tiresome. And the idea was to automate the association between the two of them to get more visibility for the customer edge, with the requirement that these two are separate to be managed. So the tool that manages the PEs is not managing the CEs. I was able to for myself, I was able to sum that up into two different parts. which were how do I get the data to associate the CE with the PE, and how do I use that data afterwards, which I'm going to get to now. But first of all, regarding the pulling this off, for example, setting up the testing network worked out of the box with Container Lab, I would say this was probably the easiest part of the whole thing, because it just works out of the box. I had a graphical user interface as well, so nice. And we get to the first question, which was how to get the data. First of all, we had the Container Lab network. We talked about this before. And secondly, I said this before, I work at Nokia, so I also work with Nokia equipment, which in this case was Nokia NSP or one IP controller, which was managing the PE nodes in this case. And now the question is, how do I associate, where do I associate the PE with the CE, which are managed separately? For that, I was using Netbox. I talked about Netbox beforehand, and Netbox was used as the inventory source for the whole network in this case. How do I get the data into Netbox? There's a lot of tools around it. I decided to go with the Netbox diode service, which is used to discover nodes and is able to populate data via SSH afterwards. And for NSP, to get the data out of NSP into Netbox, I was using a Python script because they have a diode SDK as well to populate that data into Netbox. And all of this data afterwards was then, via the diode ingestion service, populated into the Netbox. As you can see here, this especially covers all the 3 pillars I've been referring to beforehand, just to test this one network automation use case. So first, we have the containers. We have the cloud-native technology for Container Lab that you need. On the other hand, we have the network infrastructure knowledge. So you still need to know what kind of network operation systems you've been working with, and what kind of service you will need to know to be able to understand the use case in the first place. And the other one is the Python script with the software engineering to be able to properly query that data and give it forwarded to Netbox. So this use case, that way includes all of the 3 pillars just to be able to prepare a demo in this case. And secondly, how to use the data. We all know have it in Netbox. How do we use that afterwards? In this case, we have the same starting point with the network and Nokia NSP. And in this case, I was using it the other way around. So in NSP, we have a workflow manager, which is based on OpenStack Mistral. So OpenStack Mistral is open source. You have a lot of documentation on it. You have commercial NSP documentation on top. And I was using that to query the Netbox API to get all the needed CE data and incorporate that CE data into my NSP data model, so that the user, when he deploys a service, can see right away that which CE the PE is connected to in that case. And this was afterwards provided to service provisioning, where I save that data in a Yang model. I had to change the Yang model for that and deploy it onto the network. So happy days, the customer had some visibility for the CE-PE association afterwards. And this use case, in my eyes, serves as a nice example of how do I combine, or how a typical network automation use case incorporates all 3 pillars I was referring to beforehand. So, lessons, challenges, and outlook. So I would say I had 2 main challenges out of this. The first one was striving for perfection can keep you from achieving results. I'm the kind of person that just likes to dive into problems. Something is not working, I'm going to spend 2 hours on it trying to get it to work. But let's just say that way I wasted a lot of time. Sometimes I could have just done it differently. It would have taken me 5 minutes, but I wanted to solve this. But sometimes it's just inefficient that way, and I need to accept that. And the second one is thorough preparation and research is key. I was talking about the Netbox quick startup guide beforehand. let's just say I found out about this one after trying to do it myself for half a day. So if I would have just Googled it beforehand, that would have saved me lots of time. But yeah, you learn it the hard way, right? Regarding challenges, I had, first of all, the maintainability. I would say the main part that you learn in university is how to script stuff. Like I missed, in my case at least, I didn't learn like proper software developing. And the issue is how do I build something that is maintainable and manageable afterwards. That's quite a big challenge. And lasting impact. This is something I've been seeing with a few juniors actually, is that we get a topic which is nice to have, and the senior engineers don't have time for it. We work on it, it's nice, right? But it's not something they immediately need, and then it's shelved. So in that case, at least it was for me, it's nice to learn stuff, but we still want to work on something that is meaningful afterwards. So that's something, to provide something meaningful that the team can use right away is quite a challenge. And the outlook is, how can I apply the same kind of mindset to other problems? As in, we have the 3-pillar mindset. How can I break down other use cases like that to simplify them for myself and for customers? Because not everybody is into network automation right away. And if you're able to break it down to this, you're much more likely to be able to properly portray what you want to do to your customer. So, this was my perspective, at least, on things, on what I think I should learn. I want to know, what's your perspective? If you could help somebody starting out, what would you recommend? The question towards the audience. If you have a question, please raise your hand. If you have an answer, please raise your hand. Thank you.
Thank you very much for your talk. I think what I would recommend to start is with actually Linux. Just dive into Linux and also Git.
Okay. Okay, thank you.
Mark Haber, freelance IT consultant. Thank you for this talk. It was enlightening to see the view of a junior person, with me being quite senior. I would also recommend learning Linux and to talk to your older and more experienced colleagues and see whether you can find a mentor and literally sit on the lap of that person for a week or for 2 weeks to learn the ropes, and learning a new tool without real-life documentation, which is very common, happens to older people as well. That's not a junior problem.
Sure. Sure. Okay. I know there's one more person over there.
Hi, thank you for the talk. My name is Ahmed. What I also would recommend is making support. Go on the NOC or something like this and learning about the network, because there you learn really about real networks, real issues, because then you have a feeling of it, what happens in a network and what kind of issues you will get and how to solve this.
Okay, thank you. Okay, thanks a lot, guys. That was it, actually. Thanks a lot for your attention. Are there any questions?
Thank you, Emre, for these insights. We have time for some questions. Please remember to state your name and affiliation before asking your question. We will also relay some questions from Venuless if time permits.
No questions? Open.
Hi, also a question from me. My name is Florian. What would you recommend? I mean, now that you have learned about that, what are quick wins with this? Where can you get results fast? And see, okay, I can actually achieve something.
Regarding quick wins, I would say one main point is, like, I know it sounds tedious at first, but there's quite some good research material you have out there. Some people are writing very amazing blogs where you can just learn everything that you want to learn, and they're explaining it in an easier way than just reading some product documentation. We've all been through that. And these blogs, at least in my case, it helped me a lot to be able to grasp some stuff better, because it was just, let's say, explained on a human level. Does that make sense? Yeah. Okay. Okay. Thanks a lot.
Well, all right. That's a wrap for this presentation. We will be right back with the next one. Thank you.
Thanks a lot, guys.